is simple, but you still need to know how to do it. So this is the first example, right? Insertion sort. From the pseudocode to get the orders, able to update the orders, know the complexity. Okay, this is for insertion sort. And can you see the insertion sort. And you should be able to know the big O location, right? This is the mass. And so that's the same. It's like for every algorithm in our course, you should be able to know the complexity, the computation complexity in big O location for each algorithm. Okay, all the algorithms we covered, you should know that. Yeah, that's the thing. We don't cover we don't need to calculate this thing. Yeah, and then merge sort a little bit. So that's for the chapter 1. So 2 algorithm and the big O notations, you should know the complexity for each algorithm. Let's jump to chapter 2. I think for chapter 2 is all the master method, the 3 cases. I mean, you can using this way to calculate it, it's fine, or using the master method to calculate the complexity. Okay. So find the complexity. Yeah, the master part. So master method is like if the any recursions is in this form, so it can be written in Tn is equal to A times T n divided by B plus Fn, and A is bigger than 1, B is bigger than 1, and F is a positive number. So there are 3 cases. So each case is you need to know how to calculate, how to get the final complexity. Okay. Yeah, it also has some examples. So we will not cover this generally. Okay. Okay. So I will go to chapter 3. Okay. Yeah, chapter 3 is about the merge sort. And binary search. I think that's the only company chapter 3 in the binary search. This is the algorithm. And also the way to calculate the complexity. And also the powering number and the Fibonacci numbers, they are quite simple. Okay? Do you spend some time on it? Yeah, there are only 4 simple examples about using recursion method to solve some things. Okay. Yeah. Okay. So chapter 4. Yeah, chapter 4 quicksort. Quicksort is slightly difficult, I think. You should know how to calculate this pivot number, the position, and how to update it using the algorithm from the prediction method. Right, that's a quicksort. It's like for the algorithm, you should know, okay, if you're starting from the first element, and how to swap each one, and finally get the I, because the output is I is the middle point. Not the middle point, it's like where this starting point should go. Okay? everything before that I is smaller, everything after I is bigger. So you should be able to write down this, update this query or the list, and then finally you will have the I. And I think the final step is to swap line. Yeah, swap line. And so in general, if you see these kind of questions, do write down these steps, okay? Not directly write down the last one, because I also need you to write down all the okay? There are not too many. Usually, like for using this example, it only has 1, 2, 3, 4, 5 lines. Okay? And you should know that this is output. Yeah, and also the complexity for quick sort. We won't ask you about the worst case, best case, average case, but just general the complexity. Okay. 4 and then 6. Okay, I think there's nothing about 6. Yeah, there's nothing about 6. Yeah, chapter 7 is the hash table. Basically, you should know there's some hash functions. There are division functions or multiplication functions. And yeah, so this is division method. You should be able to calculate it, which I give you an example in class. Multiplication method. Actually, yeah, this one I think we have an example. This is programming strategy, like linear programming or double programming. Okay, so 2 methods. It's like if you have all these equations, and you calculate the age, the index using the hash functions. Okay. So let's. As I said, we won't ask you to prove anything, so I think the chapter 8 can be skipped. Yeah.
Chapter 9.
Then chapter 9. Yeah, binary search tree. Okay, so I think for chapter 9, only some part for the binary search tree. Yeah. We want to ask you to prove something. We will skip all the mathematical part. Okay, so only first few slides.
Chapter 10.
Yeah, 10 is the key. Okay, red black tree. You will definitely have this one. Okay, so you should, yeah. And in the example, especially for the red black tree, you might need to draw a few steps. Okay, because each step you might have to ask you to, someone is to recover, some step you to rotate. Okay, so you need to write out all these procedures, not only the final result. Okay, you will have a draft paper, so you can write down something on the draft paper, then write it on the final result. Otherwise, because especially this question, because you should write few graphs, at least 4 or 6 or even more. If you make something incorrect and you want to correct it, you will have no space. Okay. So what I suggest is, especially some big questions like this, do write it on the draft paper first, then move it to the final paper. Okay. Just in case you make some mistake. So yeah, of course, red black tree. You should know how to do all these things, from the rotation to calculate the height, the black height. Yeah, I think that's it. Okay, so you should know how to calculate black height and how to rotate the tree after insertion. Okay, this one is key. And 12, there's some geometry method. Yeah, so first one is the range searching. This range searching things. I know how to write down the output in orders from the algorithm. Also how to get the speed node and then from the range searching to output it in orders. And the key part is here is like also for the red black tree and this one, because there are also something like the the other part in symmetric, where you just swap left and right or something. It's better you just finish that part by yourself when you bring the slides. Otherwise, if you want to do that in the class, you won't have enough time. Okay, especially if you, as I remember in the red black tree, you have this thing. If you look at the pseudocode, yeah, you will see then cross this left and right swap, right? Because you might need to finish this by yourself first. Okay, so then with this, you will know how it will look like. Yeah, so this one is also symmetrically for right traverse. Okay. If you don't fix this, you should be very familiar with this algorithm. It's still okay, but otherwise it's better you just write it on the slides when you bring it. Yeah, so this is register and the cross product algorithm. I mean, especially several applications. And then the line segment in this session. It's 3 algorithms here. Okay. So then. Yeah, 16 is a printing algorithm. I think 16 and today's algorithm should be quite simple. We will definitely see them. You're able to read this algorithm and you can update it. So in the exam, you should be. It's better. I mean, for frame algorithm, we don't need you to write so many graphs. Just select some graph, okay? Because otherwise you will have too many. You can select some of them, just in case if you make some mistake, you still get If you have some part correct, you can still get some points. And you should first also get all these values correct, and also draw the final minimum spanning tree. Okay, so don't forget to add the minimum spanning tree at the end. Yeah, just follow the associated elements. Yeah, and this minimum spanning tree. Yeah, and for the minimum spanning tree, you add this error. So with this error, I know you work it out. Okay? Because this error is when you finish one point, there should be a record about the previous one, right? So this is indicate about where it collected, how you get it from. So to write this error, to add this error, so I know you actually work it out. Okay. And yeah, of course, every algorithm you should be able to get the complexity. Yeah, and finally, for today's algorithm, I think you're all familiar with it now. Not this one. Yeah, very simple. Is especially for the graph question, I will draw the graph for you, okay? So I'll give you an example. And for the result, I do ask you to write the graph in the similar way of my original graph, okay? So do not change the orders, change the positions, and then need to guess where you which point of which, okay? So if I give you the 5 points in these orders, when you give me the result, do write in these orders, okay?
Only the stress algorithm. Only the stress algorithm from this only the stress algorithm from this work.
Every graph, like this one, like the previous.
I'm looking at the borders, not the graph itself.
Yeah, but I mean, in the red tree, you also have graph. The previous.
The algorithm, not the graph.
The algorithm, yeah. You don't need to write the algorithm, you know that.
不是，老师刚才他说这个 PPT 里面就这个会 algorithm 来吗？还有其他的
Yeah, only this algorithm.
？Only this one. Yeah.
Okay.
Okay.